Assalamu alaikum. The Mann Whitney test is a non-parametric statistics test that can be an alternative to the t-test for independent samples if the normality of the data distribution in the two groups to be compared is not confirmed. When comparing the results of two independent groups to different groups, the first step is to check for the normality of the data distribution. If the data distribution is normal and it can be characterized by few parameters, then the more powerful parametric tests, like the t-test, for example, can be used. Alternatively, if the normality of the data distribution cannot be confirmed, one would consider the use of the less powerful non-parametric test, which has the advantage that it can be used on data that is not normally distributed. The Mann Whitney is a good alternative to the more powerful parametric t-test. Say we are running a trial to find out the effect of a treatment on two groups. If the data is normally distributed, then we can calculate the mean of each group and its standard deviation, and then by the use of the mean, the standard deviation, and the number of patients in group A, and the mean and the standard deviation, the number of patients in group B, we can use the t-test. If the data is not normally distributed and we cannot calculate a meaningful mean, then we use the Mann Whitney test. Here, the data would be ranked from top to bottom or from bottom to top, and will depend on the ranks. Here, for example, the highest score was number 1. Will depend on the sum of the ranks in group A against the sum of the ranks in group B to find out if there is a real difference between the two groups after using the treatment. So the Mann Whitney non-parametric test is based on ranks, not actual scores. You need to have at least 5 patients in each group. The data would be preferably continuous, but ordinal data can also be used. The samples are independent, the two groups are independent, different groups, and not necessarily equal in size. You could have 9 patients, for example, here and 12 patients on the other side. We'll go through two simple methods of calculating the Mann Whitney U, the Mann Whitney test statistic. Method number 1, say we are running a trial to compare the results of two different groups, a group of 4 females against a group of 5 males. These two groups are independent, different. And we are measuring either an enzyme or a hormone or a score of one sort or the other. And the way in method 1 to do it is to have these numbers in a table, 4 females on the y-axis and 5 males on the x-axis. This table will be a 4 by 5 table with 20 squares in it. And then we check each score of the female, number 1, against each of the male scores. So we can see that 20 is more than 19, then we mark it yes here. It's less, so we leave this vacant. It's more than 16, we put yes. Less, we keep it vacant. And then the second female, 11, would be less than all of the 5 males. The third female would be more than this score here, so we put yes, and the last female would be less than all the males, so we keep it vacant. So out of the 20 scores, the females scored more than the males in 3, and the males scored more in 17. We take the smaller, that's the 3, and that's it. That's the U test. So it's as simple as that. We just find out the number of the smaller of the two totals in this square, and that's the U that we are going to use it as a test statistic. That's about it really with the first method. The females scored more in 3 out of the 20, and the males scored more in the 17. We take the smaller of the two numbers, and that would be the Mann Whitney U, and this is the result here from the computer software. The U is just 3, and we check for the significance of that figure, if the difference is significant or not. You can see here that there is these are the results of the females and the males, and the p-value for the U equal 3 is 0.11, which is not significant. The second method for calculating the U, which depends on the ranks of the scores. So we have here 4 scores for the females and the 5 scores for the males. We'd want to combine them into one set of scores arranged from the bottom to the top, or vice versa. It doesn't really matter. So the lowest score, which was 11, belonged to a female. This will be the start of the column, a female with an 11, followed by another female with a 12. The top score belonged to a male with 29, followed by another male with 24. So we'd have the top 2 scores in here. So the 9 scores, the combined scores of the females and the males, are arranged from bottom to top in here, and then we rank them. We give the lowest score for a female is a 1. The second lowest was again a female, so that's number 2. The top score belonged to a male, that's number 9. That's the highest possible score rank. And just below that was another rank 8, belonged to a male, and so on. And then we take all the ranks for the female, that's number 1 and number 2 and number 4 and number 6, and add them separately. That will bring this sum of ranks for the females is 13, and do the same for the males. The sum of the ranks will be 32. So the sum of the two together is 45. These are the sum of all the possible ranks for the males and the females. That's the first step. And then we use the rank sum for the female, which was lower than that for the males, to calculate the Mann Whitney test statistic, the U, according to this formula. The U is the rank sum for the females minus number of the females, which was 4, multiplied by the number of the females plus 1, which was 5, divided by 2. So this is the equation here. 13 was the sum of the ranks minus the multiplication of 4 times 5 divided by 2 is 10. So the final result, the U, is again the 3 that we have obtained by the first method. The U is actually signifies the degree of overlap between the two groups. The higher the U value, the closer the results to the null hypothesis. You would expect a null hypothesis to be true, that is to say no difference between the two groups, if the U approached in this example say a score of 10, for example, because this is what we expect if there is no difference at all. But with a score of 3 you would expect some difference, but that was not statistically significant. Now, to find out if the difference between the two groups is small, medium, or large, we need to calculate the effect size. And the effect size for the non-parametric test is the Rosenthal's R, and it's obtained by this formula. It equals to the Z score divided by the square root of the sample size. and the z-score can be obtained from the u that we have calculated minus the u that would be expected. The u that would be expected for a valid null hypothesis would be 10 in this example. The 20 scores would be the 20 squares would be divided evenly between the males and the females, so the u would be the expected u for the null hypothesis is 10, and this is the actual u for the smaller group of the two. It was 3, and then we divide this with the standard error of the mean to obtain the z-score, and we use the z-score to obtain the effect size, that is the Rosenthal's R. If the effect size is less than 0.3, then it's a small difference between the two groups. If it's between 0.3 and 0.5, it's medium, and if it's more than 0.5, then this is a large effect size. By this, we come to the end on this presentation on the Mann Whitney non-parametric statistical test. Assalamu alaikum.